we're going to review lesson number 2 for the Unit 1 lecture exam. So this is lesson number 2, Discovering the Universe for Yourself. Make sure and read the lesson objectives. Okay, and then this is going to be Chapter 2, Sections 1 and 2. So those are the things that you want to read for this upcoming lecture exam. So why did the ancient civilizations study astronomy? So you should know this, okay? Go back in your notes and review this. So it has to do with they needed to know when to be able to plant their crops. And so by studying the heavens, they knew that when stars were in a certain position in the sky, or when the sun came up in a certain position, then they knew it was a certain time of the year, and then they would know that would be the time to start planting crops, and then later they would know when it would be time to start to harvest those crops. Okay, number 2, constellations. So you need to know the old definition of a constellation, which was the stars made a particular picture in the sky. And then the new definition is that it's a region of space. And so all of the stars that are in a particular region of the night sky are considered to be a particular constellation. So that even though in that on the picture that is on the left hand side you see that W thing, that's the traditional constellation of Cassiopeia. But the modern definition would be any star that is in that particular region surrounding that W. And we consider all of those stars to be part of the constellation Cassiopeia. Okay, and then you should have an understanding for what the celestial sphere is. So the celestial sphere is this sphere that surrounds the Earth, and then on it you have all of these different constellations, and so that's pictured here. Okay, you should know that constellations are three-dimensional. Okay, then we've got this formula here, which is going to allow us to be able to tell the relative brightness of objects compared to each other if we know their magnitudes. Okay, so the magnitude is going to be given by the letter M. So M stands for magnitude, and in the old days the magnitude went from 1 to 7. Okay, a magnitude 1 type star meant it was the brightest star. A magnitude 7 meant it was the dimmest star. So this is something that the ancient Greeks came up with, the magnitude scale. Okay, on the other hand, F is, so script F is going to stand for energy flux, and that's going to be the apparent brightness of an object. And so this thing can actually be measured, and you can have metric units that goes with this quantity. This thing here is just a number, 1, 2, 3, and so forth. So the formula down there in the red box is going to allow you to actually calculate how much brighter one star is compared to another star if you know the magnitudes of the two stars. So M1 is going to be the magnitude of star number 1. M2 is going to be the magnitude of star number 2. And then F1 is going to be the apparent brightness of star 1, and F2 is going to be the apparent brightness of star number 2. Okay, so in order to use this, here is a sample question. Okay, so this would be something that you should be able to do on the exam. If I give you the magnitudes of the two stars, can you plug it into the formula and then calculate the number. Okay, you're not going to have to know how to locate stars with a star chart or with a planisphere for lecture exam. You are going to need to know how to do it for the laboratory exam. Okay, you should know what the celestial sphere is, and you ought to know what the words right ascension and declination are. Okay, so that right ascension, if you draw a picture of the celestial sphere, then the lines that are going up and down, those are going to be called the right ascensions. In order to go from this line to this line, you've got to go right. So that's why they call it the right ascensions. Now, on the other hand, you have the lines that are these. And so those are going to be the declinations. And so this is going to be 0 degrees declination, and then it goes all the way up to 90 degrees up here, and then down here would be negative 90 degrees. The units for the right ascension are going to be hours. So you start off with 0 hours right ascension, and then 1 hour, and then 2 hours, and then when you go all the way around the earth, you have 24 hours, and then it starts over again. Okay, and you should know that the right ascension corresponds to longitude, and then the declination corresponds to latitude. So this is a way of identifying stars in the night sky by giving just 2 numbers that goes with them. Okay, don't worry about the phone app. You're going to do that in laboratory. Okay, then you should know why constellations can be seen only at certain times of the day. Okay, and then that's going to be because the Earth is rotating, and so the constellations appear to come up in the east and then set in the west, just like the sun and the moon. But they don't. It's that the Earth is revolving, and it makes it seem like they're rising in the east and then setting in the west. So it's going to depend on the time of day. Okay, constellations also depend on where you're at on the Earth's surface. So that if you were on the equator and you were looking at that particular constellation, you would look straight over your head. But if you were at the North Pole and you were looking at that constellation, you would say it's on the southern horizon. So it also depends on where you're at on the Earth's surface. Okay, it's also going to depend on the times of the year. Okay, so the best way to figure this out is to, if you've got the sun is going to be located here, and then the Earth is located over here, and then let's say that you're interested in a constellation that's over here. Okay, then you would very easily be able to see that constellation. But a constellation that would be over here, so let's say that this is a different constellation, you wouldn't be able to see that constellation because the sun's in the way. Okay, you would be looking in this direction at night, and you'd be able to see this constellation. So in order to see this constellation, you need to wait 6 months. So if the Earth goes over to here, now you're at night, you'll be looking in this direction and you'll be able to see this constellation, but now you wouldn't be able to see this constellation because the sun again would be in the way. So there are certain constellations that are seasonal constellations, like Orion, for example. Orion, you normally see it during the winter time, and then it gets harder and harder to find it as you approach spring and fall. And then during the summertime, you don't see the constellation Orion. Now there are, however, other constellations which you can see all the time. And so those would be the ones that are located up here. And so, like for example, the Big Dipper and Cassiopeia. So those are constellations that are so close to the celestial North Pole that you can see them all the time. But the closer you are to the equator, the celestial equator, those constellations are the ones that are hard to see. And you wouldn't be able to see constellations that are down here if you are in the northern hemisphere, because the Earth would be getting in the way. So if you live in the northern hemisphere, you look at northern constellations. If you're in the southern hemisphere, you look at southern constellations. And if you're on the equator, well, you can see the northern constellations and southern constellations. Okay, then you also need to know about precession. Now, you don't need to know about the mathematics of precession. However, you do need to know what precession is. Okay, so that if you have a spinning object, so let's say that this is your spinning object, and you wrap a string around it, you pull the string, you put it on the table, okay, it's going to be spinning like this. But you're also going to notice that it's going to, as it's spinning, it's also going to be rotating around in a big circle. And so that's going to be called precession. And it's going to be caused by the gravity of the Earth. The gravity of the Earth pulling down on this spinning object is going to make it precess. Okay, but the Earth precesses. So the Earth is tipped over at a 23-degree angle, and the Earth also is precessing very, very slowly, every 26,000 years. Okay, that's because it's feeling the gravity of the sun over here, and also a little bit of the gravity of the moon as well. But once again, it's gravity. So gravity pulling on the spin axis makes it precess. So just know the definition of what precession is. All right, so that takes care of lesson number 2. Okay, so let's take a break and we'll come back with lesson number 3.